Hello everybody, welcome back. In this session we will talk about OAuz protocols and implementations. There is a lot of implementations published, but we can't explain them all. So we will shortlist them to the one used in the market today. We will talk about OAuz 1.0a and OAuz 2. But first let me apologize because this session have a lot of information and a lot of standards, but it's very important to know how OAuz implementations work and how granting access work, because that's what we will be exploiting in the next sessions. So I hope to have some fun today. Let's talk first about some terms. Number one is consumer key and consumer secrets. It's a key and secret belongs to the client or application who requests the protected resource. It can be an internal application like the official Twitter mobile application, or it can be another website or application you want to log in to using login with Twitter button, for example. The nonce is a cryptographic number, totally random, usually 32 characters. Signed request is a request with a hash, which the hash verifies that the request didn't change. So we generate a hash based on the request content. The hash, if the content change for request, the hash will change. So the hash is here to make sure the request didn't change in any mean. OAuz token is a token generated by the backend API upon signed request. It can be a request token or access token. We will see the difference in a minute. OAuz token secret is the secret used for signature generating in most cases. Okay, let's now go to the first type of OAuz 1.0a, which called one-legged. The request here is very simple. The client sends a request to a protected resource with some informations. The server validates the information and requests the protected resource and return back to the client. That's it. And that's what request look like. This parameter sent through authorization header. The client sends the consumer key, the nonce, the signature which is the verification hash. It hashed all the requests using HMAC SHA1, with the consumer key as the hashing key, and then there is a timestamp and version of the OAuz. One-legged is the simplest way, but as you can see, it must be implemented for trusted applications only, because it has no other verifications, and if consumer secrets leaked somehow, you can access all resources without limits. Second type is two-legged authorization. This flow like this. The application request the request token. The server return the request token to the application. Application use the request token to exchange it for access token, and backend API will return the access token and access secret. So the application can use access token and token secret for accessing the protected resource after that. And this is how the requests look like. There is a number of parameters in the first request, like consumer key, timestamp, nonce, signature, and signature methods. Then the response from the server will be OAuz underscore token, OAuz underscore token underscore secret. And the second request from the application will be the same as the first request, but we add OAuz underscore token, which we received from the backend. And the backend API will return us the access token and token secret, which will be used to access the protected resource after that. Clear? Okay. Now is the most complicated one, the three-legged OAuth 1.0a. Here we add another factor, which is the user. The user must approve the authorization of the application. So how it works? First, application requests the request token from the backend API. The backend API return the request token and secret to the application. And here, the application will redirect the user to ask for granting him the access, but he will redirect the user with the request token. The user will approve the authorization of this application. When user approves this access, he redirect back to the application with request token and something called verifier. The application will take this verifier and request token and exchange it with the backend API for access token. The backend API will verify the request and return the access token and token secret. Application will use this access token and token secret after that to access the protected resource. So it's the same as two leg, but we added another leg, which is the user. Let's see how the request parameter is. Here is the same request parameter as two leg, but we add another parameter here, which called OAuth underscore callback, which is a callback for redirecting the user back to the application. We'll see this in the next example, but here this is the callback, which will redirect back the user to the application. When the application sends this request, the response the backend API will respond with OAuth underscore token and OAuth underscore secret. And application will use this OAuth underscore token to redirect the user to ask him for granting access. When the user approve the access, it redirect back to the application with this parameter OAuth underscore token and OAuth underscore verifier. Then the application will send the request to backend API with the usual parameters, but we add OAuth underscore token and OAuth underscore verifier. And the backend API will return another response with the access token and access secret token secret that will be used to access the protected resource after that. Okay. To be clear, let's have a real example of one of the most providers for OAuth 1.0a, which is Twitter. Twitter is still using OAuth 1.0a for accessing. And this example for Twitter sign-in. If a website wants to implement a sign-in button for Twitter, here is what the flow will look like. First, when you go to the website and click for the sign-in with Twitter, you want to sign with your account on Twitter. The application, let's call it localhost application. Okay, the localhost application will call OAuth / request token on api.twitter.com with this parameter in authorization header prefixed with OAuth, and here OAuth underscore. Here is the callback parameter we talked about that will redirect the user back to the application. This is the URL in the application. We redirect the user after successful granting. And here's the consumer key and the nonce and signature for the request, signature method, timestamp, and version. Here's the first request. We will access the request token. We want the request token. The website or localhost want the requested token. Then the Twitter will respond with the request token here. OAuth token. Here is the request token, and here is the token secrets. And here is just that confirmed that the callback is true. And the next step is redirect the user. So the localhost application will redirect the user to api.twitter or auth.authenticates to ask the user for the permission or access to his account. So with the OAuth token, which taken from the response from the previous request, and after user granting him the access, granting him the access, the Twitter will redirect him to the callback URL which was presented here. Okay, Twitter will redirect him here this URL with the OAuz token and OAuz verifier. The localhost application will take the OAuz token and OAuz verifier and make another request to api.twitter.com requesting for access token. Here is the usual OAuth request, but with the OAuz token and the authorization header. And in the post for this request, we will see OAuz verifier, and this is the verifier. If this information is true, the Twitter will return the OAuz token and OAuz token secret. This is the access token. The localhost application will store this information and use it when he wants to access a protected resource for this user account. This basically how OAuth 1.0a works, 1 leg or 2 leg and 3 legs. In the next video we will discuss how OAuth 2 works. So see you next time. Thank you.